Assalamualaikum. In this video, our group will be present about what of application of differentiation, which is related rates. All of us are from CS 1432A. Now, let's meet our group members. Let's begin. What is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. The reason why we use differentiation is to determine the maximum and minimum values of particular functions. To solve differentiation problems, there are three techniques that we can apply, which is derivative if sum and difference, derivative of a product function or we name it as a product rule, and lastly, derivative of rational functions that called the quotient rule. The rate of function is defined as dy over dx equals to fx equals to y. There are 5 applications of differentiation that we had learned in calculus. First is related rates, analysis of function 1 that concrete increase, decrease and concavity, maximum and minimum problems, Rolle's theorem and mean value theorem, and analysis of function 2 that concrete relative extrema, first and second derivative test. Now, I will explain what is related rates. Related rates is a problem that involves 2 or more variables that change at the same time at the different rates. In a simple way, related rates is a problem that involves at least 2 changing quantities. The rate of change usually with respect to time. In related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity that will be more easily measured. The procedure are, find equation that relates the two quantities, then use the chain rule or implicit method.
Now it's time to problem solving. The equation is a spherical balloon is deflated at a rate of 10 cm cubed over second. Find the rate of change of the surface area when the volume is 32 over 3 pi centimeter cube. The first one is we need to identify the given information. The first information is a spherical balloon is deflated at a rate of 10 centimeter cube per second. We can write it as dv over dt equals to negative 10. Why is it negative? Is it because the balloon is deflated, so we need to put negative in front of 10. The meaning of dv over dt is actually the first derivative of volume with respect to time. That means it shows how volume change with time. Second information is find the rate of change of the surface area. We can write it as dA over dt equals to, we don't know the answer. That means we need to find it in this calculation. Third information is when the volume is 32 over 3 pi centimeter cube. We can write it as volume equal to 32 over 3 pi. Second step is we need to know and write down the formula that we will use in this calculation. In this case, we will use the formula of the surface area of sphere, which is 4 pi r square, and the formula of the volume of sphere, which is 4 over 3 pi r cube. Step 3 is we need to write the calculation. In the slide, show dA over dt equals to dA over dv multiplied by dv over dt. To find dA over dv, we need to use product rule, which is we get dA over dr multiplied by dr over dv, and the result we multiply by dv over dt. Now, we need to assign the value into this equation. How to find dA over dr? To find it, we need to use a surface area, which is A, equals to 4 pi r square, and we differentiate it until we get dA over dr equals to 8 pi r. Now, we need to find dr over dv. To find it, we use the volume formula, which is 4 over 3 pi r cube. We differentiate it until we get dv over dr equal to 4 pi r squared. But in the calculation, we need dr over dv instead of dv over dr. So we just upside down it. We get dr over dv equal to 1 over 4 pi r squared. Step 4, after we know the value of dA over dr and dr over dv, we need to assign the value into this calculation. And we get dA over dt equals to 8 pi r multiplied by 1 over 4 pi r squared and multiplied by negative 10. We simplify it until we get 2 over r multiplied by negative 10. So now we don't know the value of r, we need to find it. How to find r is, we take the volume from the equation given equals to the formula of volume, and we get 32 over 3 pi equal to 4 over 3 pi r cube. We calculate it like shown in the slide until we get r equal to 2. And now we need to substitute r into this equation. We get 2 over 2 multiplied by negative 10. The final answer we get negative 10 centimeter square per second.
Therefore, the rate of change of the surface area of the balloon is negative 10 cm square per second when the volume is 32 over 3 pi centimeter. This negative rate indicates that the surface area of the balloon decreases as it deflates, which is expected because of the balloon volume decrease, its surface area also decreases accordingly. By referring to our calculation, choosing the correct formulas and accurately calculating both the first and second derivatives provide a strong solution. This method helps us understand exactly how volume, surface area, and their change related to each other. This mathematical shows us clearly how these properties of spheres connect and give us a good way to figure out what might happen in different situations.